How you doing? Excellent. Thanks for coming. Really appreciate you spending the time here this morning. My name is Richard Smith. I'm a solution architect with a core central team at Microsoft Services called Client Solutions. And my role is to work with large global customers on deploying Windows, whether that be rich client deployment, whether it be session-based desktop, or whether it be VDI-based desktop. So I work across the Client Solutions realm. And today I'm going to give you a session, deliver a session to you on notes from the field, Windows 8 image engineering. So I'm going to try and bring into this session some of the best practices that we've developed and we've learned over the course of the past year or so and beyond, working with large-scale customers deploying Windows 8 in their environments, migrating from Windows XP and Windows Vista and Windows 7. So this is the agenda for today. We're going to talk about the image engineering process, and I'm going to really stay within image engineering today. I'm not going to go outside. I'm not going to go into deployment in any way. This is all about creating the image, customizing the image, capturing it, and ready for deployment. So I'm going to talk a bit about the image engineering process. I'm going to talk firstly about requirements gathering. I'm going to give you some tips around how you gather requirements for your image engineering process. Then I'm going to talk a little bit about the image engineering way that we set up automation with particular tools and technologies to allow us to build consistent, repeatable images over and over again. And I'll talk a little bit about some automation because one of the general rules of thumb that we have is automate everything. So I'll show you a little bit about how we automate image engineering processes and the tools that we use. I'll talk a little bit about scripting, some of the scripts we use, and then we've got obviously related content and resources. So this is the image engineering process that we're going to talk about today. We're going to talk about identifying requirements for that master image. How do we gather information about what needs to be in the image? Because there can be a large amount of change that needs to take place from the vanilla image that we provide you on the DVD to what you actually need to deploy in your organization. We'll then talk about how you take those requirements and turn them into an automated image engineering process. In this case, the current recommended practice, and I'll use the term current recommended practice because recommended practice can change. So the current recommended practice is that we use MDT, Microsoft Deployment Toolkit 2012, Update 1, to automate the image engineering process. And then we'll talk a little bit at the end about automating as much as possible using the MDT functions, the scripting framework, the task sequences, and that kind of thing. So let's get started. Number one, let's talk about identifying the requirements for the master image. How do you do this? Identifying requirements notes. So this is kind of a diagram of typically how we would develop an image for deployment within a large organization. We tend to split this into 4 layers, and really we're going to be dealing with this bottom part of the layer for image engineering. In layer 1, we're talking about deploying the Windows 8 operating system, adding maybe some base core hardware support if required, maybe adding some core utilities, configuring and customizing, and then dealing with Office installation. From the point of view of what happens next, we then throw that image that we generate in image engineering over the wall to the deployment guys, and they will plug it into whichever tool they're using for deployment. Now, the Configuration Manager, Microsoft Deployment Toolkit, other tools are available. And then we layer on top of that image stuff. In this case, things like driver injection, language injection, and business-specific policy, so group policy. And then finally, we talk about layering in applications, and we typically talk to customers about 3 layers of applications. A foundation layer that everybody gets, a business layer that's specific to department by department, and then finally a layer of applications that are specific to an individual. So that's kind of our methodology around image engineering at the bottom, and then how it's deployed out. This gives maximum flexibility in the deployment. It allows us to keep a consistent image, and it allows us to patch and maintain that image through its life cycle. So The content questions. What do you put in your image? Well, the first question we typically get asked by a customer is 32-bit or 64-bit, or both. These are some of the guidelines around choosing the architecture for the image. Do you need hardware models that support more gig of RAM? If the answer is yes, then you should use 64-bit. Do you have a need to run 16-bit applications? If you do, then that leads to 32-bit. Do you have a list of standard peripherals of devices that do not support 64-bit drivers? In which case, you need 32-bit. So these kind of 3 or 4 questions are used to kind of determine the architecture of the images that we build. Now, typically, most organizations, we try and get them to go to a single image, one image. But in many cases, we have to develop 2 images, a 32-bit and a 64-bit image. The next question is, thick image, thin image, or hybrid? A thick image tends to have a lot of stuff in it. A lot of applications are installed in the image. This tends to be associated with service line agreements, SLAs. We have to build that PC within 45 minutes. If that's the case, then the image becomes larger because you stack more things into the image. But actually, a hybrid image or a thin image is a better way to go because it gives you more flexibility. It allows you to layer stuff on top of the image outside of the image engineering process. So the kind of questions we're asking here is there a large set of users who need exactly the same? What applications need to be in the master image? Is there a service level agreement where you require the machines to be built in a specific time period? And then finally, what's the deployment options? If you are an image engineering person, you should always understand how your image is being deployed. What toolkit is going to be used to deploy the image? How is it going to be deployed? Is it going to be deployed as a refresh or a replace? Are you going to use user-driven installation with Configuration Manager? Are you going to do an offline build? Are you going to ship your image to your hardware manufacturer so that they can put your image on the devices when they ship them to you? So all of these questions really lead you to how you generate and create your image. Now, that's kind of the general questions around the image. What about Office? Office 2010, Office 2013. Typically, we see 3 options for Office. And this, again, comes back to the deployment techniques that you're going to use. So first, install Office fully in the image. You run setup. Office gets installed as part of the image engineering process, and everybody gets the same version of Office, the same apps. Everything's configured exactly the same for all users because it's part of the image. Option 2 is you take Office and you package it into your deployment tool. So in our case, that's typically Configuration Manager. And then you deploy it as part of that level kind of 3, 4, and 5 that I showed you in the diagram. So you lay down your image, and then you put the Office package on top of that as an installed application. That gives maximum flexibility because the package can change. However, it's quite a large package. And if you need to do that on a mass deployment project, then it's a large amount of data to go across the network. What we tend to recommend is the third way, which is a combination of the 2. Here we install Office as part of the image, but we install Office in its local installation source format only. So we actually deliver the local installation source as part of the image, and then during deployment we reach into the local installation source with a task sequence and run setup from there. And it gives you the capability to do things like drop configuration files into the Liz before you run setup, so you can run setup differently for different types of users. But we're taking away that bulk package that needs to be transferred across the network, and we're using the WIM as an envelope to deliver that package. So that's typically how we see Office deployed to save that network bandwidth, to make it part of the image. So when I'm talking to customers about gathering requirements for their image engineering process, we typically go through a standard set of questions. What architecture do you want, 32-bit, 64-bit, or both? What's the deployment mechanism you're going to be using? Are you going to be using Configuration Manager to deploy the image? Is it going to be MDT to deploy the image? Is it going to be a third-party tool to deploy the image? What apps do you need in your image? There's typically 8 to 12 pieces of software that go into every image. You typically find a set of middleware components added to every image engineering process. So that's things like your .NET framework, your C++ compilers, the bits that you need to add to make sure that the apps that come later can work correctly. So typically, in my experience, is between 8 and 12 pieces that you add to the image. And then, what kind of branding do you want to add to your image? Do you want to put branding into the image? Do you want a custom desktop wallpaper? Do you want a custom set of information putting in the properties of computer, like the support number, support phone number, and support website? Do you want to take advantage of the OEM logo that you can put in the properties of computer and put your own logo in there? So we can do a lot of branding stuff as part of the image engineering. What features of the operating system do you or do you not want to turn on? What services, what features do we need? And then finally, what group policy do you want to add to the image itself to make it secure out of the box? So what local group policy do you want to apply? So it will be, so collecting all this information together, we end up with an approved image design. Now, it would be really, really cool if we had a really sexy way to collect all this information. And we have. So Microsoft Services has a way of collecting this information which we make available to you. For those of you who are not aware, you can go up to the Microsoft Connect portal at the link that's shown on the bottom of the screen, download the delivery.zip file, and you will get the things that I'm going to show you in the demo shortly. So to gather image engineering requirements, typically what we'll do is we will go through a process of driving a workshop with our customer. And the workshop is made up of a deck, which is on the left-hand side, and an info path form, which is on the right-hand side. So let me show you what that looks like from a use perspective. So here we are. We've got the deck on the left side of the screen and the info path form on the right side of the screen. So let me show you the deck first. The deck is really used to help drive questioning with the customer. It helps us present the options for the image and have the customer tell us what they require. So this is really a discussion deck. It's used to drive requirement gathering. So we have a very functionally laid out contents page in this deck. Each of the columns goes through a particular set of features in the image. So this first column is all about the OS and device options. So we'll work with this deck. We'll talk to the customer about the target devices, the architecture, the language packs. And we use each of the slides to position what we want to talk about, give the customer the options, and then ask them what they want, as part of their image engineering process. So we've done a lot of this work for you from a requirements gathering process. So we drive the questioning through this deck. So we can drive OS device options, we drive feature options. We've also implemented in this deck current recommended practice. So where a customer doesn't know what they want, we have default settings in there that are our current recommended practice. So again, it's a good tool to drive the discussion if you're a consultant and you work with customers, or even if you work in your own organization and you're responsible for requirement gathering, for functional specifications, for quality and non-quality attributes, whatever you want to call them. If you're responsible for gathering those things, then this is a good deck to help you gather the image engineering requirements. So the deck helps us ask the questions, present the options, and gather the information from the customer. The info path form that you get with the kit as well is designed to gather and record that information. So we use it to record the options that the customer makes. And you'll see that the info path form matches the deck in terms of color. That's intentional. We did that on purpose, right? So that it all matches together. So as you go through the info path form, you can see the the operating system and device options here. what operating system version do you want, what architecture do you want, and all of these tick boxes and drop downs are driven by answers and questions in the deck. So we gather all this information together, the make and models that are going to be supported, the patches that need to be included or excluded, the language packs that need to be installed. And then we have a notes section that we can go in and add additional stuff that's not covered in the form. And as we work through this form, we've got Windows 8 features here. We list all of the Windows 8 features that are turn on and offable within the OS. And we have the customer tell us which ones they want. We also record their look and feel options. Do you want a custom wallpaper, OEM logo, screensaver? What information do you want to apply in the properties of the computer? So we collect all of this information in the form, and we use it then to automate our image engineering process. Does that make sense so far? Yeah? Cool. All right, so we've talked a little bit about gathering the requirements for the image, pointed you at a website, the Connect site, where you can go and download the deck and the form that we use in our engagements to do image engineering requirement gathering. Let's talk number 2. This is the kind of crux of the session. Let's talk about automating the image engineering process using Microsoft Deployment Toolkit 2012. So, the basics. Windows 8 deployment basics. If you wanted to create a Windows 8 image by hand, this is how you would do it. You would build a reference image answer file, and to do that, you would use the Windows System Image Manager that's part of the Windows Assessment and Deployment Kit, the Windows ADK. You would then create a bootable Windows PE environment. Again, it's provided to you through the Assessment and Deployment Kit. And then you would build and capture a reference machine using Windows PE, DISM, or ImageX. Again, all these tools are part of the Assessment and Deployment Kit. So that's to build your image. What about deploying your image? If you wanted to deploy your image, then you would build another answer file with the Windows System Image Manager. You would set up USMT to migrate data and settings, and then you would deploy your reference image again using Windows PE, DISM, and ImageX. It's a lot of work. You could just actually use MDT. Microsoft Deployment Toolkit will do all of this. Sits above the ADK and gives you a nice interface for using all of these tools. So our current recommended practice is to use Microsoft Deployment Toolkit Update 1 as your image engineering platform. And that MDT is a platform. It's, for those of you that don't know MDT, it's a solution accelerator that's freely downloadable from the Microsoft.com download site. The latest version, the current version, released version is MDT 2012 Update 1. There is soon to be a MDT 2013 beta. But MDT is a platform. It's designed to help deployment in all sorts of ways. We see it used in the lab to do image engineering. We see it used in deployment for small companies, maybe 500 to 1,000 users. And we see it integrated into Configuration Manager 2007 and 2012 to give extra functionality as part of the deployment process. So it's a very flexible toolkit. It provides a number of different components. It provides a task sequence engine, very similar to System Center 2012 Configuration Manager and System Center Configuration Manager 2007. It has a rules engine. It's dynamically driven. So it allows you to create variables and then it will fire things based on those variables. And so that makes kind of image engineering very flexible. It has a wizard system that allows information to be presented to a user or a technician, and then they can adjust the information, and that has an impact on the deployment. So there's a lot of stuff under the bonnet in MDT, and I would encourage you to take a look at it. And if you are considering getting into deployment with Configuration Manager, then MDT is a really great place to start your learning, because you can learn all of the variables, there's task sequence and logic from within MDT, and then transfer those skills across to Configuration Manager. So again, this is where I've just gone through this, but this is where we see MDT used. We see it in the lab to automate image engineering. We see it used in its light touch implementation, LTI, light touch, to do deployment. Light touch because somebody has to be at the machine to start the process. They have to be there to press F12 to pixie boot it, or they have to launch a script to start the process. We also see MDT integrated with Configuration Manager to provide something called Zero Touch implementation, ZTI. Zero Touch relies on the Configuration Manager scheduler to start the process of rebuilding a machine or migrating a machine without anybody having to be there. So those are the key areas where MDT fits. So let's look at how we would do image engineering with MDT. So you'd have an MDT server and a reference device. From our perspective, the reference device should always be a virtual machine. We don't recommend using hardware devices to build images anymore. It should always be a virtual machine so that you have a clean image when you build it and customize it and sysprep it. So we build the virtual machine with Windows 8, the vanilla version of Windows 8 using MDT. We then customize that operating system, install our core applications, take away or add the features we need, add the customization as per the form that I showed you earlier. And then we sysprep and capture that image back to the MDT server, ready for deployment. Within the MDT environment, we initially set MDT up as a tool on a client or a server. We create a deployment share within MDT, and then we stock that deployment share with all the pieces that we need to build the image. So the operating system, the application source, the packages, language packs, updates, drivers that we may need to add to the image. And then we create a task sequence within MDT to glue all these pieces together. We configure a central file called customsettings.ini, which is all of our variables for the build. And then we have that reference machine build itself, sysprep itself, and then capture the image back to the MDT server. Actually, all of this can be fully automated. If you're really clever with PowerShell, you may have realized that MDT has a lot of PowerShell in it. And one of the things we tend to do a lot with customers is automate the process not only of running the task sequence to build the image, but also we automate the process of standing up the virtual machine, building it, sysprepping it, capturing it, and then throwing it away at the end, because we can do all that with PowerShell and Hyper-V. So we tend to build an image engineering, I suppose, process based on MDT 2012 and Hyper-V. So let me show you what that looks like from a demonstration perspective. So here we are in the MDT toolkit. So for the purposes of this demonstration, I've created a deployment share here on my server. And I've got a bunch of folders. And for this demonstration, I'm going to really concentrate on these 5 folders: apps, operating system, drivers, packages, and task sequences. So if we take a look at the first folder here, what I've done is I've used some of the processes within MDT to create additional folders. So I've used this new folder option by right-clicking on applications, and I've created a couple of new folders. One for image engineering, so that contains my scripts and my apps, and one for hardware, general hardware and Windows 8 specific hardware. So this is where I put my applications that I want to fold into the image engineering process. So we take a look at the scripts first. These are all some of the scripts we've written to automate the image engineering process. It deals with branding and customization, setting features. And then we've got some generic scripts that deal with things like adding versioning control to the registry, setting date and time. So scripts can be put into MDT as applications so that they can be picked from a list. Here we see a bunch of applications that we typically find customers asking to be engineered into their image. All of the .NET frameworks, sometimes we put the App-V client in, sometimes we put Office in as a full install, sometimes it's as a local installation source. We can even deploy Office Click to Run as part of an image. So the Office Click to Run 2013 Click to Run that's provided through Office 365. So if we take a look at one of these applications, here's a best practice from the field. When we create our applications within MDT, you would typically find here the silent install command to install this application. However, we don't use that. We have a wrapper script for installing these applications, and I'll show you that script later and why we use it. If you go to operating systems, again, I've created a couple of folders. One for the operating system installation source. So this is the vanilla version of Windows 8, directly from the DVD or the download from the Volume License Center. And then I've created a number of folders for my drivers. I've got some Windows x86 driver folders, some x64 driver folders, and then I tend to break them out via their models, by their manufacturer. And then I keep my Windows PE drivers separate in a separate folder for x86 and x64. Packages tend to deploy two things, language packs, in this case for Windows 8, or OS patches, again, x86 and x64. So it's kind of a nice way to group the stuff together in a way that allows you to organize the image engineering process. So here you can see I've got two task sequences that have been engineered for creating images. One is x86, one is x64. And the task sequence itself is based on the client task sequence template that ships as part of MDT. We've just stripped some of the stuff out of it that we don't need because we're not doing migration. We're just building a machine and capturing it. So each of the tasks in the task sequence has a phase. And it's the install phase, really, that's responsible for installing the operating system. Here, all we need to do is go across to the select an item window and choose the operating system that we've imported into MDT and add it to that task, and that task will install that operating system. As we move down, it's the state restore phase is where we do most of the customization for the customer's image. So it's here we add all of our custom scripts and custom information. One of the things that's built into MDT is the ability to go off to a WSUS server with an inbuilt script that's part of MDT and pull the updates from that WSUS server to integrate into your image. And we do it twice. Once when the OS is installed, and we run it again when applications have been installed so that we can patch things like Office. You'll also notice we use a lot of variables within our deployment process, our image engineering process. These tasks they run if a variable is set in custom settings.ini, and this is a variable, a custom variable we've created called apply Windows update equals yes. And if that's set in the custom settings.ini file, then that task will run. And the reason we don't run it all the time is when you're image engineering and you're testing your processes, you don't want it to patch because it can take a long time to patch. So we turn those off for the period that we're testing building the image. We then have other variables that control other scripts within the process. So we have a customization script here that receives variables, again, from custom settings.ini. Although it doesn't have a variable to run the script, there are variables that are passed to the script to turn certain things on and off. Same for features. In the custom settings.ini file that I'll show you in a second, we have a whole list of features we can say yes or no to. And that script will then take those variables and run commands to add those features based on whether they're set in custom settings.ini. Other scripts we have are kind of basic, Visual Basic scripts with command line parameters that we input for setting things like page files and event log sizes and that kind of thing. We then create a separate folder for application installs. So here we've got a whole bunch of applications. The first one, actually, we call it an application, but it's not. It's actually a script. It's a PowerShell script that we wrote that removes all of the Windows 8 applications that come in the box. So things like mail and finance and all that kind of stuff. We run this script. We can edit it so we can choose which ones stay and which ones go. And then this script will pull those applications out of Windows 8. And it's based on this new run PowerShell script task that's built into MDT 2012 Update 1. And again, we've got a variable in custom settings.ini that we set to yes or no. And if it's set to yes, the task will run, the script will fire, and the apps will be removed. So we go down through the applications, you'll see we've got a folder here for user experience virtualization. There's 2 tasks for UEV if you want to bake it into the image. The first task is that you have to turn on offline file service. So we've got a task to do that. This just runs a basic command line to turn on the client-side cache service. And then you've got an application install, which installs the UEV client. Again, all based on variables. And once you've kind of set up all of your apps and all of your operating systems, it's very easy to pick them from the list and add them to your task sequence. So very quickly, you can build a custom task sequence for a customer based on their requirements, the apps that they want installed. We've then got a bunch of install folders for installing Office in different ways. So we've got Office 2010, and we've got a variable in custom settings.ini that says if the Office version is Office 2010 or off 2010, then you're going to be using some tasks in this folder. And we've got then a set of folders beneath that install Office in different ways based on an Office solution variable that's set in custom settings.ini. And these then just run the commands for installing Office in its different formats. So full install, local installation, source install, click to run install in the case of Office 2013. So you can see everything's in the task sequence. This is kind of a standard task sequence that we use for image engineering. And then we can turn these things off and on based on custom settings variables. We then have a branding script that deals with the branding requirements that I showed you earlier. And this is one of the nice things about MDT is that you can create scripts and then just add them to MDT as if they were applications, and then you can pick them from the list, right? You can create a task and run your scripts as if they were applications. So that's what I've done here to show you how you can create scripts and have them run. One of the challenges we have with Windows 8 is there's no easy way, or there's no way really, that you can automate customizing the start screen. There's some basic customization that you can use in the unattend.xml file, but pretty much you have to customize the start screen by hand, and that's the easiest way to do it. So in the task sequence, we have a task which pauses the task sequence so that we can make those manual adaptations to the start screen. So I mentioned this custom settings.ini file quite a lot. This is quite a large custom settings.ini file. We've added our own properties to it. And it's a very easy thing in MDT to create your own custom properties. You just declare it at the top of custom settings.ini as a property, and then somewhere in custom settings.ini you give it a value. And then you use that value either in a script or in your task sequence. So we've got the basic wizard panes variables already in here, so we can turn them off or turn them on. So here we've got the skip task sequence is set to no, so we will see this wizard. Skip locale selection, skip time zone is set to no, so we will see this wizard. As we go down through the custom settings.ini, there's a set of settings and variables here that we set as default for image engineering. So what's the computer name going to be? Again, the wizard will show because we've got it switched on, but these values are pre-populated. The values that we put in custom settings.ini are automatically added to the wizards when they show up, and I'll show you this as a demo later. Then we move down through custom settings.ini, and we have a bunch of stuff that's customer specific. So things like what organizational name do you want to use? What's the admin password going to be? Again, we've got a wizard to change this if we want to, but we've got the default values in custom settings.ini. What refresh rate do you want as a base for your screens? What home page do you want the image to go to? So all these are set within custom settings.ini. It's then we start to get down to some of the variables that I showed you in the task sequence. In the task sequence, we've got this variable here, and I'll show you where it is in the task sequence. So on the folder for installing user experience, we've got that apply UEV equals yes. That's a variable in custom settings.ini, apply equals yes or no. And we created that property by just declaring it at the top of the screen in the properties section. So we created it, we gave it a value, and then we consume it in the task sequence. It's very easy to create your own properties within MDT. That's all you need to do. You don't have to write any code or scripts to do it. So we've got the remove WinApp equals yes. So that's going to fire the tasks within this folder, the remove default apps folder. We've got customize start screen equals yes. Remember what that does. If that's set to yes, then the task in the task sequence for customizing the start screen is going to run, and that's going to suspend the task sequence so that we can manually edit the start screen. Make sense? And then we've gone through and listed all of the features that are in Windows 8. And we can turn them off and on by making them true or false. These variables are then passed to this script, the Windows 8 features script. And that script, based on the inputs that it gets from customsettings.ne, will turn various features on and off within the image. You can see it's quite an extensive list of features that you can turn off and on within Windows 7 and Windows 8. We then have a set of settings towards the bottom of the customsettings.ini file to help us with customization. So we have settings here that are, again, passed to scripts. They're not task sequence variables. They are variables that we pass into scripts. The scripts are written as part of the MDT framework. And these scripts then consume these values when they run to turn things off and on. And it gives us a great deal of flexibility when we're working with customers. Because many customers want their own OEM logo. They want their own OEM support hours, OEM support phone, OEM support website integrating into the image. And then finally, at the bottom, we've got the variables for controlling how Office is installed. We've got the Office version, which picks which folder we're going to install from. And then we've got the Office solution, which tells the task sequence which set of tasks within that folder to run. So we've got the kind of 6 or 7 ways that we can install Office 2010 and 2013 baked in. And then by throwing the switches in customsettings.ini, we can choose which tasks run. So that's how we set up our image engineering, automated image engineering process. So let's just do a quick recap. We create a new deployment share within MDT 2012. We stock that deployment share with all of our pieces, so our operating system, vanilla image, our applications, our packages, our drivers. We then create a task sequence, and like the one that I showed you in the demo, we configure our customsettings.ini file to control that task sequence, and then we use that task sequence to build a reference machine. So that's how we set up the image engineering process within MDT. Let me show you what that now looks like from the reference machine side of things. Okay, so if you are the reference machine, the virtual machine being built, what does running that task sequence that I showed you in the demo look like? All right, so let's look at the image engineering build process now. So here we are. Here's the reference machine. And you can see we're seeing wizards being presented because of the settings that are in customsettings.ini. And the information that's presented in these wizards is based on information in customsettings.ini. So skip product key equals no, so we see the screen. Skip locale selection equals no, so we see the screen. One of the things we tend to do is at the end of our engineering process, when we've got everything correct, we turn all of these wizards off so you don't see them. So it's a fully automated process. But at this point here, we can do things like we can change where the reference image will be captured back to, the share and the file name of the WIM that will be captured as part of the image engineering process. So these deployment wizards are pretty useful when you are in your kind of development phases. Then we click Begin, and you can see the task sequence down the right-hand side of the screen as it's running, and I'm highlighting each of the tasks. We're gathering information about the device. We're formatting the disk. These are built-in tasks within the MDT task sequence. They're built-in tasks that we provide as part of MDT. And then we install the operating system. MDT 2012 installs the operating system in a very different way to how it previously did. In the new version of 2012 onwards, we use DISM, to install the operating system, to lay down the image and inject the unattend file into it. We don't run setup.exe as part of the installation. However, once the image has been laid down and a reboot takes place, then Windows Setup takes over and configures it just runs the normal setup now. What we've done is we've injected into Windows a unattend file that has a number of those variables from customsettings.ini, like the computer name and the locale and the time zone. So that unattend file has been adapted on the fly, passed to setup, and then as part of the task sequence, we re-enable you saw it flash up there, we re-enable the administrator account because we need to log in as that to carry on the build process. The reference device will now reboot, and then it makes you feel a little bit special. It's what we like about Windows 8. It makes us feel special while it's installing itself. And it gives you some user training. It's pretty cool. Yeah. Shows you how to move the mouse to the corner of the screen. Shows you how to use, if it's a touch-based device, it will tell you how to touch things. Yeah, it's pretty cool. So this is part of the standard Windows 8 setup process. You'll see this if you run setup by hand. It's baked in, so we see it as part of the image engineering process. We then get this colorful light show that flashes nice colors at us while it's building the machine. Question? So the question is, can we disable that? You can't disable the light show, but you can disable the user training piece with the group policy. But you can't disable it until you deploy the image with group policy. Well, so the question, hang on a second, let me pause this. So the question is, yeah. No, so the question is when the image is then deployed, and it's deployed out to a machine and somebody logs on, do they see that? No, that's part of the installation process. So a user, we see that because if you're a consumer and you go and buy Windows 8 off the shelf and you plug it in at home and you build your machine, we want to give you some training while it's building. But if you're a user in an organization, you probably won't build your machine, right? If you're an administrator, yeah, and you build a machine, that's going to show. And every time a new user logs in, that's going to show. But you can, once it's deployed, you can turn it off with group policy. Yeah. Okay. All right. So we're now in the full operating system. We've automatically logged in with the local admin account that we re-enabled as part of the installation process. And we're now picking up where we left off in the task sequence. We're in our kind of set of tasks now to customize the environment. So we're setting features, we're adjusting page files, we're removing the default applications. So here's the PowerShell script I showed you earlier. It's very exciting to watch. We run the task, that runs the PowerShell script, and the inbuilt applications are not only uninstalled, but they're deprovisioned, so that users don't get them as part of their installation. So now we've got a very clean start screen. We can go back to the desktop. We can see the UEV agents running, install running. Why? Because in customsettings.ini, we've got that property set to yes to tell it to install these applications. The values in customsettings.ini, we chose to install Office 2013 as a full install. Remember, it could be a Liz install, or it could be a click-to-run install, but we're running the task to install Office fully within our image for this particular customer. And then we apply our branding, again, based on variables that are in customsettings.ini. And then we're going to suspend the task sequence. Why? Because in customsettings.ini, we ticked the variable that said we want to customize the start screen. So we've paused the task sequence using an inbuilt feature of MDT 2012 Update 1. It pauses the task sequence, and it places an icon on the desktop that we can use to restart the task sequence when we've finished our customizations. So this time now can be made, you can use it to make your customizations. So here I'm going to show you some basic customizations that we tend to see customers ask us for in the start screen. Typically, they'll ask us to remove the store. We can do that either with a script or we can turn it off as part of our start screen customization here. Often they'll ask us to add additional applications to the start screen that are baked into Windows 8. So here we're going to add in things like Media Player. And we're going to make some new groupings as well with these applications. We're going to start to move things around a little bit, place them specifically for the user. Often, if Office is part of the image, the customer will ask us to create an Office group of applications. So again, here we're moving the icons over and creating a standalone group for the Office-based applications. In this case, the communications apps are at the top, so Outlook and Lync. Then Word, Excel, PowerPoint, Access, OneNote, in whatever order the customer requires. So this is a basic kind of start screen customization for the initial install of the device. And then we may get rid of a couple of the Office application tiles from the start screen. We're then often asked to create additional groups for tooling that may be used. So here we're going to put SkyDrive on the far right-hand side. And another useful tool that we add to the desktop, particularly during proof of concepts and pilot deployments, is the Problem Steps Recorder. This is a tool that the user can use to record issues that they're having that are then zipped into a zip file, and they can send them to the team so that we can analyze the problems they're having. So this is kind of a standard look and feel. We then go in and kind of rename these groups. So we might call this, My Desktop, call this My Applications, encourage the user to add their icons to this environment. Here we've got the Contoso apps, and then some support apps or some utilities that the user can use as part of the deployment. So we end up with this kind of customized look and feel start screen. Very quick to do, a couple of minutes, and we're done. The reason we do this in this process is so that the admin profile can be captured and copied over the default user profile as part of the image and as part of the process. And then finally in this task sequence, we're going to do a restart to apply all of our settings before we come back into this machine, log back in automatically. And the next process we're going to do is we're going to run sysprep. Actually, first, before we run sysprep, we're going to download to this device a Windows PE image so that we can boot into Windows PE after we've run sysprep to capture an image of that machine. Because you can't capture an image of the machine from the running operating system. We have to be outside of it. So in the tasks, in the task sequence, in the bottom set here, in the folder at the bottom called Capture Reference Image, we've got some tasks for applying a Windows PE image to the device, changing the boot order so that we boot from it. Then we run sysprep automatically as part of the tasks in that folder. And then once sysprep has done its work, the machine will reboot into the Windows PE environment where the task sequence will pick up again, and it will then capture an image of that device, capture the WIM of that device back up to the MDT server. So that's kind of the fully automated process that we have for setting up the environment with lots of variables so it can be changed quickly, and then what it looks like from the point of view of the device itself when you build the reference machine. And remember, this should be a virtual machine. Again, I'll go back to the point that actually one of the things you can do is automate the process of creating this virtual machine, right, and tie it into MDT. So that actually you can just press a button and a VM is stood up, it's connected to MDT, it's built, it's captured, it's customized, it's captured, and then we tear the machine down at the end. Question? Yes? Yes. So, yes, so the question is, we've got a lot of automation in there, except for the part where we organize the start screen and the apps. You would think there would be an API to be able to do that. There isn't. You would think there would be an easy way for you to script the creation of tiles and movement of tiles. There isn't. The only automation that you have really to fall back on is there are some settings in the unattend.xml file that allow you to create up to 24 tiles in the start screen and to create a number of groups and group those tiles into those groups. And that's about it. You can't move tiles that already exist on the start screen or in an automated way. So at this point in time, at this current point in time, the recommended practice is to manually create your start screen. Once you've created it, you can capture the bin file that sets up that screen, and you can then deploy that bin file to other machines. And actually, in Windows 8.1, that's much easier now because you can deploy that file with group policy. And you can lock the start screen in 8.1 so that it can't be changed. But in Windows 8, unfortunately, we have this process where we have to manually customize that start screen. But it's baked into the automation process. I'm with you. I want to automate everything. I don't want to touch the machine. Yes, you could. You could do that. You could create your bin file once, and then as part of your image engineering process, you'd have a script that imported that bin file. So I'm showing you the manual way to do it. There is an automated way to do it, but you have to do the initial build in a manual way. There you go. Yeah. So once you've done it once, you just have to adapt it if it changes, if you want to change the start screen. Okay, so great questions. So we've talked about requirements gathering. We've talked about turning those requirements into an automated process for building an image and capturing it. Let's touch on the final part of the presentation now. We'll talk about automating as much as possible using scripts and MDT functions. So this is the automation nodes. A couple of things that we hit around operating systems. There's a process within Windows 8 and Windows 8.1 called reset and refresh. This is the capability to set the device back to a default state. A bit like your OEM can do. When you phone them up and you say, hey, I've got a problem with my PC, they say, hey, run system recovery, and give us a ring back if you have any more problems. How many people do you think ring them back when they've had their machine rebuilt to how it was when it was delivered? So the same kind of functionality exists within Windows 8 and Windows 8.1. Customers often ask us to create a recovery image and put it in a hidden partition on the drive, particularly for field users and laptop users, and then have it available through this function. And that is possible, but we do not recommend it. And the reason we don't recommend it is because there's no really easy way to patch and manage that image once it's been deployed. So actually a user kind of 6, 8, 9, 10 months down the line who hits the recovery button and puts their machine back to how it was when it was first delivered to them is going to be unpatched, right? And it's going to take time for them to get up to date in their patching. If your image relies on things like direct access, and they're coming in and they're being analyzed as part of the connection, and they're not patched up to date, then they're not going to get a direct access connection. So all of this kind of has a knock-on effect to the user experience. So we don't recommend using the refresh and reset for custom images, purely for the fact because it's difficult to maintain. UEFI is another area where we see a lot of questions at the moment around deployment to UEFI devices. Your devices need to be UEFI 2.3.1 or above. That's the minimum standard, release standard. Windows Deployment Services in 2008, Server 2008, has difficulty detecting UEFI-based machines, but it's fixed in 2012. And if you are offline building, and I've had this a lot at the conference this week. You know, we gave you the ISOs yesterday for Windows 8.1. So everybody rushed off and created their bootable USB device and extracted the ISO onto it to use to build their machine. Don't format your USB device as NTFS. If you have a UEFI-based machine, it expects to see FAT32 on that device to be able to boot it. And that gives you a limitation on the file size for the WIM. So if you've got a large WIM, that's not going to fit properly on a FAT32 partition because there's a 4 gig limit. And what you will then have to do is then you will have to split your WIM into smaller files and then glue them back together during the deployment. So these things catch you out. And then the other thing is the start screen customizations. One of the things that always catches customers out in Windows 8 at the moment is that if you customize the start screen as part of your image, when you deploy that image, the image must be a member of a domain for those customizations to then fall through to the user. If it's not a member of the domain, you get a default start screen. Right? So that's a key thing. Make sure that the machines you're building and deploying are domain-based, and they are being logged into by a domain user. Windows 8 IE10 icons that you paste onto the start bar, on the desktop, onto the taskbar on the desktop, they will not be preserved. They will end up as kind of broken links with the broken link picture on them instead of IE10 icons. So if you put any icons on the start taskbar on the desktop, they will disappear. They don't survive the sysprep process currently. And then copy profile is our prescribed and supported way of deploying customizations. I often get the question, why don't you just use Configuration Manager to build your images? And then use Configuration Manager to deploy that image. Why are you using MDT to build images and Configuration Manager to deploy images? And the simple question is, we can do the customizations that I've shown you today with MDT in a supported way. We can customize the admin profile, we can change the desktop, change the wallpaper, customize the screens, and then as part of the deployment process, we have our unattend file that deploys the image with copy profile equals true. Copy profile equals yes in the unattend file. And as part of the process of laying down the image onto the new machine, the admin profile that we customize during image engineering is then copied to the default profile, so every user will then get those customizations. If you are doing it in any other way, it's unsupported. If you are writing scripts to mount registry hives and change settings in the registry as part of a System Center Configuration Manager task sequence for image engineering, then that is unsupported. Copy profile is our prescribed and supported way of doing customizations from the admin profile to the default user. Now, the reason we use MDT and not Configuration Manager is Configuration Manager does not run in the context of an administrator. System Center Configuration Manager runs in the context of the system. So whose profile are you going to customize? There isn't one to customize as when Config Manager runs. With MDT, we always run in the context of the local admin, which is the account we customize and then copy across to default user. So that's the main reason for that. Scripting-wise, don't be afraid to write scripts. Write your own. But take a look at MDT. It has a fantastic scripting framework. We provide a whole bunch of scripts, and we provide a whole bunch of library scripts as well. I'm going to show you a couple of them in a minute. Use them as samples. Use them to do things in the task sequence. Don't customize the core MDT scripts. You'll lose those customizations if you ever update MDT, because we'll overwrite those scripts as part of the update process. So don't ever customize the MDT scripts, the core ones, but use them as the basis for new scripts that you want to generate. MDT is a framework. It's a platform. We provide a number of library scripts to help you with your scripting. So we have this mammoth ZTI utility.vbs script that provides all sorts of functions into your own scripting world. You don't have to write code to do logging. You don't have to write code to do utility-based functions. They're all in this script. And all you need to do is reference it from your own script. If you want to make changes to the boot configuration database, you don't have to write the code to do that. We've done it for you. It's in this ZTI BCD utility.vbs script. If you want to configure and capture network adapter settings, you don't have to write the code to do that. It's in this ZTI NIC utility.vbs script. You just call it and then consume the functions within it. And if you want to do disk engineering, if you want to create partitions, get information about disks. You don't have to write that code. It's in this ZTI disk utility.vbs. So across these 4 library scripts, you have almost every function you will ever need to do any kind of deployment. Sorry, were you taking a picture of that? Do you want it back? OK. All right, so how do we go about scripting? Well, all scripts that we create within MDT are typically XML-wrapped VBS scripts. They have the WSF extension. We always include a reference to ZTI utility.vbs. It's the main library script within Microsoft Deployment Toolkit. It then provides us a whole bunch of global instances that we can leverage in our scripting. So O environment, O login, O utility, shell, file system calls, environment, and even WMI calls. It provides all of this code for us in one script. You then write your own script with that reference, consume the global instances, and then put your script into the distribution share scripts directory where it will be called from. And that's pretty much it. If you're running the script in MDT, you drop it in the distribution share scripts folder. If you want to run the script in Configuration Manager with MDT integrated, then you would put it into the toolkit package that MDT creates for you in Configuration Manager in the scripts directory, and then in your task sequence, you would reference it as percentage script root percentage. And we map back to that package for you automatically. So you don't even have to worry about where you're running the script from. We do all of that for you. From a scripting note perspective, logging is taken care of thoroughly within MDT. The ZTI utility script will, if you use it and utilize it correctly, will create a log for you automatically of every script you build, named the same as your script. It will then populate that log with the information that you put in your script. By using the O-logging create entry global call, you can then put information into that log. And the log file is exactly the same format as you get in Configuration Manager. So you can use trace32, trace64 to view the log, see the errors, see all that cool information color-coded. We've got environment properties, so we can set variables or substitute variables. One of the things we often have to try and do when we're running scripts is figure out where the script is running from, right? The path to where the script is. ZTI utility provides those functions for us. So we just call a function from ZTI utility, and it builds the path for us from where the script is running from. Utilities for finding files, validating connections, looking for credentials, UNC paths. He was taking my picture then, I think. All that's built into the ZTI utility script. So it's a great tool to start your scripting world with. In terms of a sample script, this is a very simple sample script that you would do in MDT. You can see we're calling ZTI utility there with the SRC flag. And then in our script, we're adding controls from ZTI utility in our script. So O-logging create entry would create an entry in the log called hello, with the words hello world, and log that as an info. So you can have info, error, and warning. And they will show up as red, yellow, and white in trace32, trace64. So very simple to add logging to your scripts with MDT. Very simple to automatically set variables in MDT. So you can see here, oenvironment.item custom is being set to test. That's the same as creating a property in custom settings.ini at the top of the screen called custom, and then giving it a value in custom settings.ini called test. That's what I did earlier. I showed you earlier in the demo. This is a scriptable way of doing that. So earlier, I mentioned that as part of when we set up MDT, one of the things I showed you earlier is when we set up the deployment share, it has two things. It has a share path, and it has a local path, where the files are stored locally. Now, when we import stuff into MDT, things like operating systems and applications, all of that source is placed in that distribution share folder. One of the things I showed you earlier is we don't use the standard install command, silent install command for the app. We have this wrapper script that we use. And this is a kind of top tip, really, because it saves you a bunch of time. Let's go and take a look in that distribution share folder. So here's my DS create folder. So this is the kind of file system side of MDT. And then in the applications folder, you can see all of the apps that we've got staged. So I showed you earlier the Acrobat Reader application. And this is how we set up our applications. We've got this wrapper script that we use. First thing you'll notice, it references ztiutility.vbs because we use some of the functions. The reason we use a wrapper script is for a couple of reasons. Firstly, we can do a whole bunch of logging as part of the installation. But more importantly, we can look for a pattern in a file. One of the things that Adobe does when they release a new version of Acrobat Reader is the first part of the name is always the same. So actually, what we do here in the first part of the script is we look into the directory with the source, and we try and find a file with that pattern. And then we build, from that file, we build a complete path to it, to the source folder and the name of the file. And what that means is every time Adobe releases a new version of Acrobat Reader, we just drop the source into the folder, and the script will always run it. We never have to change an install command line. The logic in the script is really finding the file, building the command line, and then running the installation with the switches for that application. Does that make sense? It makes it very nice and easy for us to update our MDT deployment points with new versions of applications as they come out, and then not have to worry about going back into the applications in the workbench and changing all of the installation options because the file name has changed. So we build that logic in. We've got a whole bunch of logging that we build around that, and then we run the installation command line from the variables that we make in that script. So that's really why we do that. It makes it easier for the customer to maintain after we've left, because we just tell them, hey, go and get the new versions, drop them in the folder, and you're good. You're good to go. PowerShell is everywhere in MDT, not only from the point of view of using it in the deployment, but also from the point of view of automating setting up MDT. You can fully automate a complete build of the MDT itself. You can use PowerShell to create the folders, build task sequences, import applications, import operating systems. You could build a fully automated system that stands up MDT ready to build your images. So PowerShell is everywhere within MDT for management of MDT, but it's also built into the task sequence now. So you can write PowerShell scripts, and the new PowerShell task in the task sequence will take care of the PowerShell policy settings. So you don't have to worry about making sure that the machine has PowerShell policy settings for your script to run. We take care of that as part of the task. We set the policy, we run the script, and then we set the policy back again. So PowerShell is very handy in some circumstances when you're doing certain types of automation, particularly if you're using MDT to deploy servers. We do a lot of PowerShell automation when we build servers with MDT. So this is a very simple PowerShell example. Very simple set of commandlets: write host to the script directory, write verbose, write warning, write error. All these can be put into your PowerShell scripts. Even pulling back variables from MDT, like the IP address, and then writing that into a log file. That's pretty easy with PowerShell. All of these PowerShell commandlets are available within MDT. These are PowerShell commandlets particularly for managing MDT. And one of the things you need to really understand if you are working with PowerShell in MDT and you're using PowerShell to automate MDT management is you really need to understand what a MDT persistent drive is. That's the key to PowerShell automation in MDT. A persistent drive is the logical linkage between the workbench, the interface that you use, and the folder on the file system where the deployment share sits. It's a logical link that PowerShell uses to access that environment. So that's the first thing to look at, MDT persistent drive. And then all of these commandlets are available for doing things like importing a package, importing a driver, importing an app, importing an operating system. You could script everything, right? You could absolutely script everything for setting up MDT to do deployments. From a tips version for PowerShell, get to know the commandlets, log, and log again with PowerShell. You have to log to be able to understand what's going on. Understand what a persistent drive is. I've just mentioned that. And actually, PowerShell will be a great way to automate implementing MDT. You know, if you wanted to install MDT and then configure it to do image engineering, you could have a big PowerShell script that did all that for you. So actually, you're automating the building of the automated system that's going to automatically build your image, right? It gets very complicated. So we have talked requirements gathering. We have talked setting up MDT to do automated image engineering tasks. And we have talked about automating as much as possible with scripts and functions. That brings me to the end of this session. I've got about 4 minutes left. If there's any questions, I'm happy to take them for the next couple of minutes. If you don't want to ask a question here, I'll be on the mobility stand, which is the Windows to Go stand, in the expo hall from 1 o'clock till 3 o'clock this afternoon. If you have any questions and you want to talk deployment, please come across and see me there. There's a number of sessions that this talk is related to. There's some hands-on labs as well you can grab for working with MDT. And some resources here from the track. Please go off to Channel 9. You'll find this recording there very soon from this session if you want to revisit it. MSDN, TechNet, and our learning site. And some links on this slide here point you at some of the management side of our environment, Intune 2012 R2, and Windows Server 2012 R2, and System Center. So these were made available this week as well. So if you haven't already downloaded them, they're available up on MSDN. You've got Server 2012 R2, Configuration Manager 2012 R2, and you've got Windows 8.1 Client from this conference this week. So you've got all the pieces that have been released this week available now. So please, if you wouldn't mind taking the opportunity to rate the session, use the tag, or fill in the evaluation, it really does give us great feedback about what we should change and what we should adapt. I'll be here for a few minutes if you want to ask questions, but I really appreciate your time. I really appreciate you all staying and not leaving. So I understand that during TechEd week there's a lot going on. There's a lot of sessions to see. So I do appreciate you coming along and spending your time this morning. Thank you very much.